Focus on building applications, not on maintaining servers.
And the second talk will be by Florian Lenz. Florian studied business informatics, is a Microsoft Azure MVP. I've had the joy to talk to him last week, I think, in a meeting where we talked about what he's going to do. He's really good at talking. He's really a nice person for that. He organizes the Azure Cloud Native Meetup in Cologne, which is a little bigger than ours. And he does podcasts, YouTube videos, meetups, a lot of accessibility work for Azure. And he is really deep into cloud. And he is a business consultant for cloud solutions with Azure.
All right. Thanks for joining, and thanks for the pizza and the drinks. And I have a topic for you today, which is probably something you didn't notice in the Rust environment. And to be honest, I never worked with Rust. I don't have any ideas how to compile Rust, but I have 4 examples, and I hope you understand it because I don't understand it. But I had as well with Jan today a conversation, and or at least I was in the mind that this topic is not about the technical perspective of serverless, it's more about the domain knowledge and about the mindset of serverless. And I think it's a good information for you that you just get this idea what serverless is, why I think it could be a great idea for your next greenfield project. And at the end, I just want to inspire you a little bit what serverless is. And when you want to work with it, feel free. But as I said, it's not a technical deep dive in serverless with Rust. First of all, so we figured out it's something like here it's working, here it's not working, but we will find it. This is me. I already heard the introduction of myself. So this is me. I'm Florian. I'm an Azure consultant of freelancing. So I do it for myself and always for myself. I have a YouTube channel, a LinkedIn blog, a podcast with Gregor Bieswanger. Maybe you know him, but probably not because he's more in the .NET environment. I'm as well a volunteer firefighter. I go to the gym sometimes. People say, you look like a gym guy, and then you have some nerdy pullover or t-shirts, and then everyone knows, okay, you're an IT guy, this is working. And as well, my girlfriend always said, my skin looks like Alpina Weiß, so it's basically the lightest white you ever see. This is probably because I said... Yeah, right. So from this perspective, it's good that I'm not too dark, but yeah. So, but first things first, you don't need to scan it. It's from a previous presentation, and since I'm working with this laptop, I thought like we just do hand raise. First of all, is here anyone who knows serverless? Okay, nice. More than expected, to be honest. The next question, who worked already with serverless in a customer project? Few less, okay. Okay, nice. For everyone else, you will see some examples of big companies which use serverless. And I think when these big companies use it, it could be as well a great fit for you. First, let's have a look what serverless is. And for me, the journey begins around 5 years ago. And I thought serverless is function as a service, so AWS Lambda, for example, or Azure Functions. I think there's as well Google Cloud Functions. So basically for me it was like serverless is function as a service. And then I worked with Azure Functions and I worked in the Azure environment, and I figured out there is as well a database which you can run in serverless mode. Okay, then probably it's not function as a service, maybe it's something different. And then I figured out message broker is as well possible in a serverless mode. And then I was like, okay, it looks like it's not function as a service equals to serverless. Maybe it's pay as you go. And then I thought, okay, maybe it's just pay as you go, because function as a service, for example, you can run it, you pay only for the requests, and for databases it's the same, you pay for the requests. So it's pay as you go. And then I figured out there's as well container instances or container as a service. And I was like, okay, maybe serverless is not pay as you go, it's not function as a service, but what is this serverless? And to be fully, to be clear, for me, it's still today not 100% clear what serverless is. I guess it's a big word with a lot of things. And for me, today, serverless is a thing of mindset. So it's not about technology, it's not about Azure Functions, it's not about databases, whatever. It's about the mindset. It's something you have in mind and a way of work. And this is why I would say there is something called serverless first mindset. And there are people who say serverless first mindset. To be honest, mostly in the AWS environment, not in the Azure environment, but I like this term, to be honest. Because serverless first mindset means at the end that you do not reinvent the wheel all the time. When you start with an online shop, for example, do you build everything from scratch? You start with this marketplace, you start with a backend for some people, you start with the online paying model. No, to be honest, you start with Shopify, for example, or take WordPress, whatever. So you take building blocks which are still there, and you just create something new and add these things you really need. And this is what serverless, at least for me, is about. Because serverless is someone else take care of the computer, takes care of scalability, of security. When you have, for example, a payment API, someone takes care that this payment API is secure. And from this perspective, for me, using an API could be as well serverless when you think of a mindset, not from a technology. And this is
without on-premises servers, but all these APIs, databases, software as a service running on servers in the cloud.
for sure. So there's always a server.
Yeah.
There's always a server, right? But at the end, there is someone managing the server for you. So from my perspective, just as a software developer, when I use, for example, Azure Functions, scalability, security, operating system, I don't care. Yeah, Microsoft is doing it for me, and I just say, hey, your job is that it's running, my job is to create a new function.
Like DNS in Azure, for example.
Yeah,
Very
yeah.
easy. That's
Exactly.
Software as a service.
Exactly. It's a great question. When I started with all the serverless and I explained like, this is serverless, blah, blah, there was someone said, okay, when I just use a database and there's a SQL server admin and he takes care of everything, is this serverless for me? And I was like, from you as an individual, yeah, it's some kind of serverless when you have serverless as a mindset in your mind, yeah. So, and this is for me what I think serverless is, focusing on what brings value to your customers, your company, you yourself, whatever. And this is exactly what this talk is about. Because there is a Gartner survey made 2 or 3 years ago, I guess. And the result was that only 40% of developer time is about value creation. And 40%, this means at the end, maybe we have Wednesday, tomorrow, and on Friday I don't need to work because there's no developer time value creation. So I just don't care. At the end, the result should be the same. And when we have a look what our job is, this is not good. I stay here for a few seconds because there are a lot of clicks made now. First of all, for sure, everyone knows that we love coding. Maybe we love defining data structures. This is for sure something we need to do every day. But then there's more. Today, with cloud and all the things, we have CI/CD pipelines. Okay, fine. Managing tickets and stories, and at the end there is a product owner who wants to get some information. We need to do it. But does this bring value to the end customer? I don't think so. But it's our job today. And then there are the setup of operating systems and infrastructure management and backup recovery and availability management. And at the end, security patches and system monitoring and the best of all, meetings. So, when we have a look to this, I guess most of you say, probably 60, 80, 70% of this, do it, whatever. And when we have a look, maybe these are the things which brings really value at the end. Maybe management of tickets and stories is, yeah, we can discuss about it, but at the end it's good when someone knows from a product team what's happening, but it's not what we really want to do. System monitoring is depending on what we want to monitor. So when we have a look to our application itself, I would say it's good when we as a developer know that everything is working, but I don't want to have a look to the virtual machine at the end. This is something I don't care, or doing patches, security patches or whatever. And yeah, the rest, to be honest, as well, meetings. Most of the time there is a business value that we find a better solution, a faster solution, or find the solution faster. And this is what I think serverless is all about, to focusing on the things which really brings value and not all the rest we need to do, because all the rest is done by Microsoft, AWS, whatever, but not from me as a software developer. So with serverless, we want to focus on building applications, not on maintaining servers. The first use case I brought is this little machine from the company, I guess everyone knows already, it's Coca-Cola. Does anyone already use this machine and knows this machine?
No.
A few, okay, nice. And yeah, this machine runs in the back end with serverless. So when you use this machine, there is a serverless function, to be honest, in AWS, but it's serverless at the end. And the story behind this thing is in 2020, there was this thing I think everyone knows about. You need to wear a mask and all this stuff. And in the US, obviously in the US, people started not using this machine anymore because you need to click on this touchscreen, and maybe when in front of you there is someone with COVID and clicks on this machine, it could be that you get COVID as well. So yeah, better we don't use it anymore, and yeah, I don't want to get it.
Different type of thing, not push on the same location.
Yeah, right, yeah.
Something nobody likes.
Yeah. Okay, I don't take Coca-Cola, I took Fanta because the front, yeah. No, but this...
A good solution would be that the design is changed every time.
Oh.
So that each button changes position and then it's...
Yeah. Maybe next time Coca-Cola should call you and not his product team, yeah, because Coca-Cola found obviously out less people are using this machine anymore, and they for sure want to sell drinks. And the question was, what can we do that people use this machine again, and yeah, and they don't have problems like, oh, I can get infected or whatever. And yeah, it's a little bit small, but here you can see a QR code. And the idea was just every one of us has a phone with you. So why do you need to click on this machine? Why not just scan with your smartphone the QR code? Yeah, select your drink on your phone, press enter, and then you get your drink served without touching this machine. And for me, when I created this talk, I never saw this QR code. And I know there is a Five Guy store in Munich, and this year in February there was the OOP conference. I was in Munich and I was like, okay, I just go to the store to check if there is a QR code and if I can really use it, and it worked. So I was quite impressive and was like, okay, I know there's some serverless stuff behind this. So, but what does this look like? At the end, this is it. So basically, there's just a QR code on every machine to identify which machine is the one I stand in front of. We have the front-end part, this is the part here. So we have just an S3 bucket. It's at the end just a blob storage, and storage where you can store HTML files, etc. We have a CDN. In AWS, it's CloudFront, and a web application firewall, a little bit security is a good idea, I guess. So this is the front-end stuff. When you have the front end on your smartphone, you can use every functionality, and the functionality is sent to an AWS Lambda function through an API gateway, and based on, for example, if there are any information about is there still cola available or not, they take data from the DynamoDB and they call for sure the machine to serve the drink at the end. Yeah.
Is the QR code randomized every time, or am I able to, if I look into it, and then I'm already somewhere else. I could like.
I like the people here. They're good-minded. Good question.
Or it's just the website. But
Yeah, okay, but we can reload every time.
I mean,
yeah.
Coca-Cola probably doesn't care that the drink goes into the thing.
But,
They made their money.
but I like it.
It's a feature.
Next,
colleague.
yeah, okay. Next time in Munich, I will try it out, and then I. Oh,
The cinema in Bochum has it as well.
yeah, the Cineplex. The Cineplex, yeah.
UCI.
UCI, yeah, right. Yeah, in Cologne there's as well as UCI, yeah, right. Maybe I try it there. Yeah, but basically, as you see, it's just a web application, and you can change this with a Docker image. You can change it with a server. Yeah, at the end, it's just just a functionality, just an HTTP endpoint, for example. And if you wonder why this is everything done with AWS, and I'm wearing something with Azure, unfortunately, this is made by AWS for Coca-Cola, not with Azure. And I like these small pictograms and those icons, and so I don't want to just write API gateway. I like this icon, so I was like, okay, it's done in AWS, and then we use it in AWS. But for sure, you can do it in Google Cloud, you can do it in Azure, you can do it as well. Yeah, on your on-prem servers, it's possible for sure as well. The result was quite good. Coca-Cola found out people are using it. It's fine, everything is good. And most important, as you can see, and here there's a quite long URL, with this you have information of your customer, and your customer has your product on his phone. So basically you can do more, and you can, for example, make some marketing movements with the phone. So when you have the information of this customer, you have more information instead of just there is someone pressing Coca-Cola, but you don't know who this person is. And at the beginning, the idea was that you can start with bigger functionalities. As far as I know, there's just this QR code functionality. But the idea at the beginning was bigger. But what is even more impressive, you just saw there are not that much functionality, but how much time do you think does it take for Coca-Cola to create this app, let's call it app, and bring it live? Just a hand raise, who thinks up to 50 days? 50 to 150 days? 150 to 250?
Depends on the quality of the developers.
Yeah, that's right. Okay, funny part, the first MVP was released after 1 week. The final result, and quite good, is 100 days. So after 100 days, they finalized this product, released it in every state in the US, and the product was done. And this is why I think serverless is really great, because they just created the functionality or the infrastructure. They said we need some compute infrastructure, we need database infrastructure, we need some security. This is there, and we don't care about scalability. We don't care about security. Everything is done by AWS, and we can focus on bringing the value. And this was, for me at least, quite nice. Quite nice to see that this is working. But there's another big company, and I think every one of you knows it. The company from this little guy. This is LEGO, right. The Millennium Falcon was released. I don't know if it's available there. I don't know, maybe 5 years ago. 5, 6, 7 years ago. There was a big release party. And they thought it's a great idea to release the Millennium Falcon, have a big party, announce it really, really big. And then hopefully a lot of people will pay $850 for a Lego set. The result was that no one bought this because the website was not available. So there was a lot of traffic and a lot of people tries to buy it, but the problem was that there was one service, and probably was the billing service, which is quite important when you want to buy something, which was not available, and this was at the end why the whole website was not available, why no one could buy this product. This was for LEGO the starting point to say, okay, we want to focus on customer experience, customer value. We want to focus on our customer and not on all the infrastructure stuff and on running all the compute resources. We just want a great website and we want to focus on the customer. And with this, they started the new, let's call it serverless website. So by focusing on business value. I mean, everyone knows this, privacy, preferences, cookie banner, whatever. But this is, for example, currently running serverless. At the end, it's basically just an HTTP endpoint. But you can run it serverless. So you have this AWS Lambda function, and you don't care about scalability. You don't care how much it costs, because at the end, when no one visits your website, it doesn't cost you anything. So at the end, you just don't pay anything. When there are 1 million customers, you pay for this 1 million customers. And I'm not 100% sure what the price is, but it's maximum $1 for 1 million customers. So when 1 million customers go to the website and interact with this cookie banner, you pay for 1 million customers round about $1. So this is the consent banner at the end. But there's more currently running. Like every good website, there's a recommendation section. So when you click on a lot of Star Wars things and you have, for example, Christmas in a few months and you think, okay, maybe my child wants to have some Star Wars again, then this is a quite good thing to sell more and upsell your customers. And this is done as well serverless. It's a little bit more complex, but at the end, it's as always the same process. We have an API gateway, so as well it's again some HTTP endpoint only. At the end, we want to get all events in an AWS Lambda function, and then this AWS Lambda function sends data to, for example, a recommendation system, an analytics system, A/B testing system, whatever. So at the end, this is some kind of message broker. It's not a message broker, but it looks like, because you can just subscribe to this AWS Lambda function, you can get all this website event tracking information. This red circled area I go into now is doing some important things, because what I said, 1 million customers or 1 million requests cost $1. When you have 1 million customers on your website, and for example, here you see, for example, event type is page load, which means when you have one customer going to 10 pages, it's 10 million customers, or at the end, 10 million website event tracking events. And this means at the end that this function is running 10 million times. The question is, do you really need to run 10 million times near real time to get this information in a recommendation system? Probably not, because at the end, it's just a page load. Worst case, a customer clicks directly on a product, says, I want to have it in my basket, pays it, and everything is fine. Maybe the recommendation system doesn't get this information. Probably he will be longer on your website, and then you can just use this so-called Kinesis Firehouse. What this service is doing, right? Every event is stored in this Firehouse, and then we have just one so-called blob stored in the S3 bucket. So at the end, we have a list of events in a blob, so just a file. And every minute, this Firehouse sends data in an S3 bucket, and the information are stored in a big blob with probably 10 million events, for example. And the AWS Lambda function just gets one request, getting all these 10 million events, and then can process with recommendation, analytics, etc. And for systems which don't need to be real time, this is a quite good approach, because you will see an example later on where this was not a good decision to have serverless in a project, because this is the next example. So first of all, what do you get from serverless? at the end, you get always enough resources. This is the good thing at Coca-Cola, for example. At the beginning, they didn't know how many people will use this new solution. Probably it could be that less and less people are using Coca-Cola because everyone was about healthy life, etc. So maybe it's better to just drink water instead of cola, Fanta, etc. So the idea to start with a serverless approach was quite good because when 1 million customers are using it, you pay for 1 million customers. When you see that 100 million customers are using it, you pay for the 100 million customers. And when you start with a great architecture, it's quite easy to change it later to a non-serverless model from a functionality perspective or from a pay-as-you-go perspective, that you say, okay, it's maybe too much request, we move to a different, and then we don't pay this much anymore. Yeah, pay only for request is an advantage and a disadvantage depending on where you stand at the moment. And for sure, and this is for me basically the most important point, and I didn't talk about it yet, but you get data and metrics. When you start with a greenfield project, or at least for me, I never got the information. We know exactly that 5 million customers will use it. We know exactly they use it from 8 o'clock to 12 o'clock every Monday and Friday. And we know exactly, it was never. It was like, we have in total 5 million customers. Maybe 20% will use this new application. It could be 50%. We do not know exactly. And this is the great thing with serverless, or at least with pay-as-you-go, because you have always enough resources. You pay only for the request, and you can start with getting data and metrics and find a solution and an architecture which really helps you to get a better architecture. So at least you start with a quite good architecture, and with every iteration you get it to this architecture which really is necessary for you. And the last one, I talked about it 5 times now, you focus on the application and not on the infrastructure. So, and I talked a lot about all these great things of serverless, and then, Amazon, so the company which said you need to use serverless and microservices, created a blog article with the title Scaling Up the Prime Video Monitoring Audio Service, Prime Video Audio Monitoring Service, and reducing cost by 90%. And then, which is quite important, the subtitle, the move from a distributed microservice architecture to a monolith application helped achieve higher scale, resilience, and reduce costs. When you only read this article, title and subtitle, you think, okay, so serverless, I don't need it. Microservices, I don't need it. I just use monolith, and then I have higher scale, resilience, reducing cost. And when Amazon has told us that they are using it as well, great, I don't use this anymore. Yes and no. First of all, what is this audio-video monitoring service? Basically this. And for every one of you who watched a film on Amazon Prime, you used this service without that you know that you use this service. Because every frame, audio and video, is going through this process because, as you see, monitoring service, they want to check if the audio and video quality of your stream is great. So in total, a good service, and something I would say, okay, it's good that you have it. So what's happening? Every frame is sent to a media conversion service. This service splits audio frame and video frame, and both frames are stored in a bucket, S3 bucket. Then there is a step function. In Azure, it would be an Azure Double function. At the end, it's some kind of workflow orchestration, you can say. This function starts the video monitoring function and the audio monitoring function. These functions do some quality checks and stores the result with an aggregation function in a S3 bucket again with the information, this frame looks good, everything is fine. And when this is not the case, then, I don't know, there's a big red light running up in Jeff Bezos' bureau and you get a call. I don't know what happened there, but at the end, this is a process. And I talked about you have always enough resources and you pay only the requests you have, and yeah, when you have a look here, yeah, this is when you change something. Yeah, this is what I just called to you. At the end, you have always enough resources and you pay only what you have. So basically, traditionally, you have a server, and then you have 2 servers, you have 3 servers. With serverless, you have just as much as you need. And which is more important is this slide. Because these 5 points are the big problems in this architecture. At the end, we have 5 write or read operations to an S3 bucket. S3 bucket is as well serverless or pay-as-you-go. And we have 5 AWS Lambda functions, which means at the end, for every single frame, we have 10 requests. And you pay for every request. And yeah, a movie, 24 frames at least for a movie per second, which means when only one of us is watching a video, 24 frames or 24 requests per second happen. Yeah, 24 requests multiplied with 10. At the end, we have a lot of requests just for one person. And not only one person is watching a movie in parallel. At the end, let's say 10 million customers, then there were 1.2 billion in English, Milliarden in German, write or read operations per second, and 1.2 billion requests to an AWS Lambda function. And when you pay for every request and you have so much requests per second, to be honest, then pay-as-you-go is not the right thing for you. This is totally clear that you can save 90% of costs when you have a quite bad architecture, then it's easier to save 90% of costs. So let's have a look what the service looks like now. At the end, they are using an ECS. This is then just a container running. And yeah, everything is running in this single process. There is an orchestrator function, we have the media converter, we have audio detector, video detector, we have a result aggregation. And at the end, we have one frame goes in and one result goes out into an S3 bucket. So we have at the end 2 requests for every frame. And yeah, to be honest, it doesn't look like a monolith. For me, at least, there's a result aggregation, there's a video detector, there's an audio detector, there's a media converter. Yeah, maybe it's a little bit clickbait that they say it's monolith. No, it's the end, it's just a container. But okay. But this is, for me at least, the most important quote, and this is from Adrian Cockcroft, an ex-Amazon VP. And he said, the Prime Video team had followed a path I call serverless first. I don't advocate serverless only. And I think this is, yeah, quite the best quote, because as always, at least for me, when you start with a project and you start with an architecture, it's not about this is a final solution, this is the end game, and this is the best result we could ever create. Most of the time it's about this is a good starting point. And when we find out later on serverless is not the solution anymore, we can go to the next step. For example, containers. Or we say maybe on-premise even better, then go to on-prem. It's never like we do it only this way and then we never change it. Yeah, and another employee, there was no one's name, just a quote, so I cannot say who this said, but someone from Amazon. This allowed us to reuse a lot of code and quickly migrate to a new architecture. And I think this is as well a good quote, maybe the second best quote, because at the end, and this is what I think is the most important, when you start with serverless and have in mind that you will change your architecture probably in the future, maybe in a year, maybe in 2 years, maybe in a month. But when you start with the right architecture, you can quickly migrate, reuse all the stuff, and you can change everything in a few months, at least maybe a few weeks, and then this is totally fine. And I created this talk, and I talked with my wife about it, and then I was like, I need a meme, I need a GIF, whatever. I need something to show what I mean with start serverless, but yeah, don't advocate serverless only. And then maybe you know what this GIF. And I think this is exactly what serverless is. It's like you're going up really quick. You can focus on your application, you can focus on your customer, and you start with a great beginning. And then after time you find out, okay, now maybe there are too much customers, pay-as-you-go is not the right thing, maybe we need to change something, but then you can change it and you get new traction and go faster again. And then by using it multiple times and re-architecture all the time and try to find the best solution all the time, you will be at the end quite faster just when you start like, we try to find the best solution and maybe in a year we have an architecture that could be the best fit, but no, maybe we need to change again. So just start fast, start with serverless, and rethink your architecture always. So, and this is the end originally, but I got the information we are at the Rust meetup and you want to see some Rust code, and for me it was like, I try. So basically, let's have a few more minutes to check what the technical part is. At the end, in an Azure function, for example, it's just a function, a method. So it's just some kind of code where you can write whatever you want. And there are multiple triggers. For example, a schedule trigger. So every day at 3 o'clock in the morning. Or an HTTP trigger. So just an HTTP trigger. But as well blob storage. So when you store something in a blob storage, when something created, you want to trigger a function. When there is something in an event hub, in storage queue, whatever. So there are a lot of triggers. And when something happened, a function is executed. So the first trigger is basically HTTP trigger. I guess everyone knows what an HTTP trigger is. And now we start with the thing I don't understand. This is what a Rust Azure function can look like. From what I understand, you define bindings. Bindings are, for example, an HTTP request and an HTTP response. And then you have your function, for example, greeting, and you just say hello, and then you get the information from parameters, from query parameters. You combine it somehow, and then you return it. So this is basically what an HTTP-triggered Rust Azure function can look like. And now you can start with calling other APIs. You can start to store things in a database. You can whatever. So it's a normal HTTP request with all the things you have in an HTTP request. Then we have time trigger. And here it's quite the same, but for sure you have now no bindings, but what you have is a schedule here. So basically you just say in this, how is it called? Unix time cron, thanks. So basically you just say, for example, every 5 minutes or every 5 hours, get 5 minutes is this, you just run this function. And then in this case, you just log Rust Azure function run. So, but you can as well call a function, call an API, call store data, whatever. So it's basically just something wrapped around your functionality. And to not bore you, this is a blob storage and this is a queue. And basically, because I guess you asked me today, how is this, or how can I debug it? Basically, it's just in your IDE. So there is no, you do not have to go into the cloud and you program in the browser. No, it's just, at least for C# functions, you have your IDE. For me, for example, it's Rider or Visual Studio Code. I just write everything. I can build it, I can run it, I can debug it. It's like every other system, and there is no new way to learn. Basically, I guess this is it. This is it. When you have questions, feel free to ask. And basically, please don't ask me anything about Rust, sorry. But other questions?
Yeah, thank you for the talk. I see one hand here. So we start with a question from Tadeo.
I have a question. Can I use serverless in some capacity if I have some kind of long-running process? For example, let's say there is a game. You have 10 people walking around. The server needs to stream some data 20 times a second to these people. And I don't want to have any lags in between. I don't want any AWS instance to go down in between or something. I just want to have a time frame where I really consistently get data and send data to the server. Are there serverless solutions for that?
Yep. Basically, there are Azure Functions, which are mostly for short-running functionalities. But this durable functions, in Azure called durable functions, it's about workflow orchestration, and this is for long-running tasks. And for this exactly, you can really great start with such a functionality. So yeah, durable functions could be a solution.
Okay. Are there questions online?
None currently. As I have a question, did you try deploying a Rust Azure function?
I didn't try it, no.
Oh, okay, I was just curious.
But to be honest, Rust is on my list to learn it for, I don't know, 3 years now, and I always like, I want to, but I never got the chance. And maybe today was quite impressive, the first talk, so maybe I try to start now.
I have 2 questions actually. What do you think? Why is like there's a very big market penetration of Microsoft and Azure in Germany when you look internationally, and why do you think is what do you think in comparison? Like you just had the AWS things. What do you think? Why is that way? Like why is AWS seeming to be much higher?
I guess the problem from Azure was a long time that they started with Azure Functions. Now we go to a little bit more nerd talk, but I guess it's okay. Azure Functions, as I said, you pay per request. In Azure, it's called consumption plan. And there are premium plans where you have a fixed amount of instances, which doesn't look like pay as you go, because at the end then I have again a server and I don't pay per request, I pay for the instances. Okay, but you can use this consumption plan, and the problem of this consumption plan was that there are no network security available, because only in a premium plan, and it was cold start problematic was quite big. They didn't find a great solution for it, and I think this was a long time a big problem, because customer from me, who started with serverless, was like, oh great, yeah, we want to use Azure Functions, and then they found out, but consumption plan, there is no VNet integration, so we cannot use it in our private VNet. We need to use a premium plan. Okay, but then we can go back to app service plans, and yeah, then just don't care about. And I guess last year, Microsoft announced a new plan called Consumption Flex. I don't know why Flex, but it's the new consumption plan, and yeah, it's better, it's greater, it's cheaper, but the most important, you have all this VNet integration stuff, you have less cold starts, and what I think is quite nice, you have the possibility to have one instance always on. You pay for this for sure, but you don't have this cold start problematic. So you have one instance always. When there are a lot of requests, you don't care, it's fast, and when there are more requests, which cannot handle by this one instance, you can just, or it's then pay per request, and this is a great solution, I guess. And yeah, so I released it last year, I guess, until everyone knows about it, etc. It takes time. So this is maybe one thing why it's, currently is more like AWS, because they started the right way.
Yeah, I think to be fair, Amazon has also the advantage to be the first in the game.
Right.
And I think it's also a bit about eating your own dog food in this case. Robin, you had a question? Take the mic.
When another serverless function calls another serverless function, how do you prevent loops? And how do you prevent going bankrupt?
You can set a limit.
Yes, set a limit, set a alert. Funny thing, nothing to do with Azure Functions, but I had one colleague of me had the situation that they used a serverless approach in a different product, and on Friday they just shut down the laptop. Next Monday they opened it, and then there was like, oh, a big bill, 60,000 euro. Was not that nice. But to prevent it, to be honest, document and check what you do. So there's currently there is an endless loop. It's like, just check it.
There's another question.
I've got two as well. About other Azure functions, is there a limit how complex they can be? Because you only pay for the call of the function, and if you make it really complex, is there maybe?
Yeah, but it takes time. So at the end, it depends. When you have an HTTP trigger, for example, you want to get a fast response for your customer. So at the end, you don't want to make it too complex. And there is as well a constraint because it's about time. So you pay for the time the function is running, and you pay for the request and for the memory during the whole request. So at the end, when you have, for example, one function called one HTTP trigger and you download 1 GB, you pay for this 1 GB as well. But in most cases, when you have a normal function, this memory usage is, you can just ignore it because it's basically, not a problem. It's more like the request, which is a bigger problem. Therefore, for this bigger functionalities, you can use, for example, double functions. There are as well other calculation how you pay for it, as well with request, and then there are as well some other metrics. But at the end, as I said, for example, maybe one example from a customer of mine, we had around 100 million requests. I guess they paid 300 to 500 euros. So it was like, on the other hand, when we use an app service plan, for example, so in compute resource, we pay the same in this, So basically, from a pricing perspective, when you don't have some endless loops, it's not a big problem.
Oh, okay. And the other question, are the functions compiled locally on your PC and then uploaded to like the Azure cloud, or are they compiled on their hardware?
You compile it on your computer or on a CI/CD pipeline, wherever, and then you just publish it. It's basically like so in .NET, for example, it's like an Excel file you just upload.
Thanks.
Yeah. Are there any more questions? Is that a hand? No. Well, thank you very much. That was very cool. I was always thinking like about this typical use case when you want to reduce cost, for example. Like you would, in many cases, you would move to another architecture, put it in an how it's called, E2C or EC2?
ECS.
ECS, yeah. I think the other one is also around. Cool. Then, thank you very much, and give him a big hand of applause.